Let's have a look this chapter, which is the load balancing part. Through this, I will share the information regarding the link load balancing and also the server load balancing. First of all, let's have a look the ECMP, which is the equal cost multi-port routing. This is the protocol that strategy where the next whole packet forwarding to a single destination can occur over the multiple path in the routing metric calculations. So this is the one that we support to achieve the link load balancing. By default, the ECMP function is enabled in the device. You can specify the maximum numbers of the ECMP routes, which is from 1 to 1000, 1 to 1000. If you set the value as 1, that means the ECMP will be disabled, The route lookup for the packet will be normally based on the longest matching principle. If there is a detailed route at the routing table, as you can see from here, it will be matched by the packet. If no exact route matched, it will go to check the default route, which is the longest matching principle in the ECMP. How we do the intelligent link load balancing from our firewall? By default, Houston Firewall will detect the link state in real time, and will dynamically adjusting the forwarding priority of different links to achieve the link dynamic equilibrium. So that is we called intelligent LLB. If you enable the link load balancing at the firewall for the multi-link load balancing, so the device by default will detect the link status at the real time, to monitor the link status, which link is in good quality and which link is in poor quality, as well as the bandwidth utilization status. And it will automatically switch the traffic to the high quality links, The intelligent load balancing, link load balancing include those stages. First of all, the detect. So the link, as I mentioned, all the link quality will be detected by the system for the link status, including the latency, the jitter, the bandwidth utilization at the real time. And the system will set the traffic ratio for the different link based on the detected results. The high quality link will forward more traffic in priority. If the link quality become bad, for example, higher bandwidth utilization and also big delay or big packet, the large packet loss rate for the specific link, the system will adjust the link traffic ratio automatically. And the high quality link will have bigger ratio, and also the poor link will have the small ratio for the traffic forwarding. And if the link quality restored for the previous poor quality link, the traffic forwarding ratio will also be automatically adjusted for the links due to the real-time detection, due to the real-time detection. So this is we call intelligent LLB, intelligent LLB. So we will detect and monitor the link status at real time, So how to configure, or how to make sure this intelligent LLB can work in more accurate way. First of all, you need to configure the interface and assign the actual bandwidth for this interface link, because this bandwidth set at the interface will be used to calculate the LLB occupancy rate. So you need to set the actual bandwidth for this link. And after that, you can create the LLB profile, to set the utilization of the bandwidth. So the bandwidth utilization, that means if the utilization over the set threshold, the system will start to do automatic judgment and switch over, or modification for the priority ratio. And there are two balance mode. One is we called high performance, another is called high compatibility. If you set the high performance mode, so that means as long as the device detected any big data loss or long delay on the packets or high bandwidth utilization in the link, it will automatically change the traffic ratio and switch the traffic to a high quality link. If you choose the balance mode as a high compatibility, so that means if there's any poor quality link detected, at the real time, the device will not change the current traffic or switch the current traffic to other link, but it will follow the current session to forward the following traffic, and then the new coming traffic will be switched to high quality link. So that is the high performance mode and high compatibility mode. It depends on the customer requirement. Especially for some finance customer, the banks, they need to assure the compatibility and stability of the sessions. Because if the traffic switched immediately from one link to another, that will cause some disconnection of the service. So in this case, you can use the high compatibility mode. After the profile created, you also need to create a LLB rule to bind this profile to a destination route or policy-based routing. So link load balancing will be supported through the destination route, as I mentioned. If you set the same precedence value for multiple destination route, the traffic will be loaded in load balance. Or the PBR, so you can use the policy to control the traffic that route the traffic through different link. So that is the destination route based and policy based LLB. After that, if you want to see the real-time status of the link, you can also enable the link state monitor, which will calculate the traffic information of the specific interface, including the latency, the packet loss rate, and also the jitter, the bandwidth utilization. In this case, we will provide the monitor the monitoring information for the overall status of the link. After you enable this, you are able to see the real-time link state monitoring from the WebUI, including the jitter, latency, packet loss rate, and also the bandwidth utilization information. So that is for link load balancing. Another scenario the customer may need to use is the server load balancing. So server load balancing used to distribute all the incoming traffic from the internet to your multiple internal servers by using the balancing algorithm, which can fully utilize the resources of your internal servers. The DNAT functions is used to support the server load balancing. Our firewall support 3 types of the SLB algorithm, which is the weighted hash, the default algorithm, the weighted list connection, and also the weighted round robin. You can configure this SLB algorithm through the command line. If you enable the sticky, as I mentioned in DNAT, so all sessions from one single source IP will be mapped to a fixed server IP. As I mentioned, the server load balancing will be supported through the DNAT. So first of all, you can create the SLB server pool, which that used for the destination translation from the public IP to this server pool, And then you can bind this server pool entry to the DNAT. Here is the example how to create a SLB server pool. You are able to choose which algorithm you need to use for the server load balancing. And also you can add the members, which is the servers, how many servers with the server IP, the port, which is the service port, and also you are able to set the maximum sessions that's supported for different servers. And you can also add the track object to track the status of the different servers of your different servers. After that, you create a DNAT joule to translate this public IP to all your internal private server IP as a server pool. If you have multiple internal servers in server load balancing. So all this incoming traffic will balanced to different internal servers.